What if you no longer had to plug your electric vehicle into an electrical socket for charging? What if there was a much lighter, cheaper, and greener battery that uses just air, water, and the metal aluminium to generate electricity and does the job more efficiently by giving a driving range that's more than double that a lithium battery offers? A long-range, lightweight, cost-efficient, recyclable, and ethically sourced battery is, arguably, the holy grail of the EV market. Although lithium-ion batteries have been driving a revolution in electric vehicles, we typically see ranges of 300 miles or less, which may not be enough for long trips depending on where you live, and nobody wants to wait for a long period of time while recharging on a road trip, or to struggle finding a nearby fast charger. But the downside of lithium-ion battery is that, if the battery is completely discharged, it can no longer be recharged again. Lithium battery risks like battery degradation from temperature variations, leakages caused by mechanical stress, and overcharging and discharging. These issues have left the door open for researchers and companies around the globe to find better alternative battery technologies. The aluminium battery could become a reality thanks to oil marketing giant, Indian Oil Corporation, and Israeli clean energy startup, Finergy, that are working on commercializing aluminium air batteries for EVs in India. Aluminium air batteries produce electricity from the reaction of oxygen in the air with aluminium. The formula is quite simple: aluminium plus air equals power. A reaction of oxygen and aluminium in the air creates electricity and leads to a charge that can be used. They have one of the highest energy densities of all batteries. Aluminium air battery for cars is an innovative technology. Let's take a look at how aluminium air battery works. A prototype has been developed with 25 aluminium air cells stacked in a series and is being tested in electric cars with Maruti Suzuki, in electric trucks at Ashok Leyland, and in electric three-wheelers with Mahindra and Mahindra. The technology behind aluminium air batteries is simple. If you are familiar with hydrogen fuel cells, as we talked about it in this video, you can check out if you want. This works similar as hydrogen fuel cells. According to Trevor Jackson, an engineer and former officer in the UK's Royal Navy, began experiment with aluminium air batteries in 2001. Although the aluminium air battery was invented back in the 1960s, it was deemed unfit for commercial deployment due to its electrolyte being dangerously caustic and poisonous. Now back to the working. The fuel is aluminium metal known as the anode, which reacts with the oxygen known cathode around it to create power. Since the cathode is just oxygen from the surrounding air, there is no need to carry the weight of another metal like a conventional battery, and this makes it considerably lighter. Air is sucked into the cathode system containing a catalyst, in order to speed up a chemical reaction to separate the oxygen molecules from the air and other components of air by the silver-based catalyst that blocks CO2 from entering the battery, but it allows oxygen to pass through the electrolyte in order to react with the water and produce negative hydroxide ions at the anode. Positive ions of oxygen react with the aluminum, causing the formation of aluminum trihydroxide, which is a white powder, and electrons, and it's those electrons that mean we can generate electricity when the battery is connected to a load like a light bulb. These electrons move from the anode to the cathode, to give back those electrons that were lost during the chemical reaction. In simple words, the oxygen that gets sucked into the aluminium air cell from the air reacts with water and aluminium to generate electricity. The best part is that, once the aluminium has been fully eroded, the battery can be reloaded with a new anode and fresh electrolyte. For consumer, it means just swapping the used battery for a new one. Jackson believes that the aluminium air batteries are a very appropriate extension for EVs. These batteries aren't rechargeable, but Indian Oil thinks that they've already figured out a solution, which involves making it quick and easy to replace and recycle the batteries. According to the company, the battery can be replaced within 3 minutes, and Indian Oil service stations can be used as swap stations. As Jackson says, "In my opinion, people don't want to wait for an electric car to charge up when they need to go somewhere. Whereas with our battery, we have a 90-second swapping system. Mobility to us is a very important freedom. That's our philosophy." A 2018 Harvard study suggests that a more accessible, easy-to-use, and relatively inexpensive charging infrastructure is needed to ensure the commercial success of EVs. While battery swapping could greatly reduce the waiting time for EV drivers, the technology is difficult to implement. The use of the aluminium air battery in passenger vehicles is just the beginning. The amount of energy that can be generated with aluminium air batteries is significant and opens up a wide range of possible uses. A lot of people don't realize that the space shuttle's solid rocket boosters were powered by aluminium powder. Possible uses for this bundled power include the marine sector, such as container ships and cruise ships, airport ground support equipment, and powering rural microgrids. Super high density, low weight eco-friendliness, and good recyclability have also drawn a lot of interest for marine applications. Yara Marine Technologies created a startup accelerator program called Yara Marine X earlier this year, aiming to support startups pioneering green marine technologies. So, what are the differences among these two batteries? Aluminum is the most abundant metal available in the world, and it isn't expensive or complex to recycle. On top of that, these batteries weigh less compared to lithium batteries, because aluminum, which you're probably already aware of, is extremely lightweight, which makes it a great choice for the anode. The oxygen that's used in the cathode doesn't need to be stored, since it's pulled from the surrounding air. Aluminium air batteries are constructed from plastic, aluminium, and a non-toxic safe electrolyte. They can be air-freighted wet or dry and are not flammable, in contrast with lithium-ion batteries, which are vulnerable to thermal runaway. They also cannot be short-circuited as there is no stored charge. They are a power source rather than an energy storage device. Aluminium air battery have the highest energy density of 8 kWh per kilograms, as compared to 1 to 1.5 kWh per kilograms of lithium and others. That's why an EV, using the most evolved lithium-ion battery, offers only a 100 to 150 miles range per charge. While with aluminium, even with half the energy density, you can still get a 4 times higher range. To put that in context, a Tesla Model S has an estimated range, from a single charge, of 370 miles. According to Jackson, replacing a standard Tesla lithium-ion battery with an aluminium air device of the same weight would produce a range of 2,700 miles. Aluminium air batteries require no electricity as they don't need to be charged. The aluminium hydroxide solution generated in the used battery can be sent to a recycling unit to get 100% aluminium back. Aluminium air battery technology is safer because it uses only a water-based electrolyte that is free from toxins, unlike lithium-ion technology, which uses organic toxins-based electrolytes that are highly inflammable. Aluminium is abundantly available globally. Nothing is perfect, and neither are these batteries, as the major disadvantages and challenges is that it is not rechargeable. Once the aluminium anode is consumed by its reaction with atmospheric oxygen, the battery will no longer produce electricity. It just stops working and has to be replaced. Imagine traveling at night and missing the fact that your long-lasting battery is almost out of charge and swapping stations wouldn't be available everywhere. A regular EV can get a tow charge from an equipped tow truck, or a small top-up from a portable battery no matter where they are. An aluminium air battery would have to be towed to a battery swap station. That's a big problem. They are not widely used because of problems with high anode cost and byproduct removal when using traditional electrolytes. Another problem is the cost of materials that need to be added to the battery to avoid power dropping. When it comes to cost, aluminium is still very cheap compared to other elements used to build batteries. Aluminium costs 2.55 cents per kilogram, while lithium and nickel cost 15.75 cents per kilogram and 18.75 cents per kilogram. Aluminium air batteries have a high degradation rate due to aluminium corrosion, while lithium batteries have a 5% degradation. After a month of being used, aluminium air batteries lose 80% of their capacity. Tell me what you think about this technology. Should it be good for EVs or not?